Hello, good evening, respected tutor. My name is Makrand, student ID Z38236830001, and I'm from Malacca Learning Center. My course is Bachelor of Science in Project and Facility Management, semester September 2024. I'm conducting this video recording for subject EBCT3103, Construction Technology. The title for today's video presentation is IBS and BIM Pioneering Sustainable Construction. Today, I'll be presenting on two key advanced construction technologies, which are Industrialized Building System (IBS) and Building Information Modeling (BIM), and how they contribute to sustainable construction practices. Both of these technology have proven to be game changers in modern construction, addressing the critical need for sustainability, reducing environmental impact, and optimizing project outcomes. As the world faces increasing challenges related to climate change and urbanization, the construction industry is under immense pressure to adopt more efficient and environmentally responsible practices. In this presentation, we will explore the role of IBS and BIM in meeting these demands. With a focus on Malaysia's leading pharmaceutical company Kotra Pharma M. Sendrian Barat warehouse project, a transformative infrastructure and operational initiative taken by the company. Through this case study, we will see how these technologies can be significantly impact sustainability, efficiency, and overall project success. Now let's get overview of IBS and BIM in sustainable construction. Industrialized building system IBS refer to modern construction techniques where building components such as column walls and beams are manufactured in a controlled factory environment and later assembled on site. This off-site production improves quality control and reduces construction time significantly. The precision offered by IBS results in fewer errors during assembly, less material wastage, and a higher overall construction quality. Additionally, IBS reduces the reliance on on-site labor, making construction faster and safer. Building information modeling, on the other hand, is a digital representation of the physical and functional aspects of a building. Unlike traditional design models, BIM incorporates detailed 3D data of a structure and integrates various elements such as the project's life cycle, material use, costs, and energy performance. BIM creates a collaborative platform where architects, engineers, and contractors can work together in a real time, using shared data to make informed decisions. This holistic approach enhances communication and reduces costly mistakes, while also allowing for accurate simulations of energy efficiency, sustainability, performance, and future maintenance needs. Together, IBS and BIM contribute significantly to sustainable construction by optimizing material use, reduce waste, improving energy efficiency, and lowering the carbon footprint of projects. They enable construction teams to design and build in a way that not only meets modern sustainability standards but also ensures that projects are delivered on time and within budget. Now let's deep dive into our case study warehouse project of Kotra Pharma Malaysia Sendrian Barat. Kotra's new warehouse project stands as one of the most ambitious infrastructure initiatives among others taken by the company in recent years. This project aims to address the growing problems of insufficient space, inefficient, laborious manual finished product, and raw material transfers from manufacturing plant to current warehouse, which is not sustainable due to heavy reliance on fuel consuming lorries and trucks, and also increasing regulatory compliance in warehouse operations management. The project scale, complexity, and its emphasis on sustainability makes it an ideal case study for exploring the use of IBS and BIM in large-scale infrastructure. The warehouse project was driven by the need to reduce heavy reliance on manual intensive laborious material transfer, which are using traditional manual driven pallet jack from packing hall to quarantine area and then transfer to finished product warehouse in block A, which is at different nearby location, using lorries and trucks. Also, raw and starting and packaging material transfers from warehouse to respective production areas done in similar way. Moreover, customer delivery are also being managed by traditional way of picking the products from warehouse racks using pallet trucks and then manually placing and picking them for customer delivery. This traditional practice is very labor intensive, consuming substantial energy and not sustainable in the long run, obstructing companies' growth. By providing an efficient and reliable robotic automated guided vehicle AGVs, automated storage and retrieval system ASRS for automated picking and placing pallets and comprehensive integrated warehouse management system with software management, Kotra's management is expecting to improve its warehouse and manufacturing operations efficiency and at the same time reduce overall carbon footprint of its operation. Sustainability was embedded into the project from the right from the start, with IBS and BIM playing crucial roles in achieving the project's environmental goals. These technologies enabled the project to reduce construction waste, improve the energy efficiency of the warehouse, and streamline the project timeline. Through the integration of IBS, many of the components used in warehouse construction and infrastructure were prefabricated off-site, reducing material waste and on-site construction time. BIM, meanwhile, was used to manage the complex network of stakeholders involved in the project and ensure that sustainability targets were met at every stage of the product lifecycle or project's lifecycle. Now let's understand IBS implementation in this warehouse project. In the warehouse project, industrialized building system IBS were extensively used, particularly in the construction of pre-infrastructure, the prefabrication of components like walls and its panels, columns and beams, ASRS RAS structure, overhead breach structure, example girders and columns, HVAC and utilities components took place off-site in a controlled environment, ensuring that the quality of materials and craftsmanship remained consistently high. This prefabrication process allowed for better precision in component production, minimizing human error and material wastages. Once manufactured, these components were transported to construction site where they were quickly and efficiently assembled. One of the key advantages of using IBS in warehouse project was the reduction in on-site labor requirements. Since much of the assembly work had already been done in the factory outside, the need for manual labor at the construction site was significantly decreased, which not only reduced labor costs but also improved worker safety by minimizing exposure to construction hazards. From sustainability perspective, the use of IBS resulted in 30% reduction in material waste compared to traditional construction methods. Prefabrication also allowed for a significant reduction in construction time, up to 25% faster, thereby minimizing the environmental impact associated with prolonged on-site construction, such as air pollution, noise, and disruption to surrounding communities. In addition to reducing waste and improving safety, the energy savings achieved by using IBS were substantial. The streamlined construction process meant that fewer resources were needed on-site and less energy was consumed by the machinery equipment during assembly. Now we move on to BIM implementation in the warehouse project. Building Information Modeling (BIM) was a central tool in successful planning, design, and execution of the project. BIM enabled the project team to create a digital twin of the entire warehouse spaces and rooms, its HVAC systems and utility systems such as electrical trunking, distribution boards, and air handling units, locations and chiller, water piping details, etc. Lighting system providing details and estimations of illuminations requirements, providing a detailed 3D representations of every aspect of the project from the design of the building to the layout of the rooms. ASRS racking and expected housing of 20,000 pallets and enabling calculations of required steel for project. This digital model incorporated not just the physical elements of the project but also data on materials, energy use, costs, and environmental performance. One of the most critical aspects of BIM is its ability to facilitate real-time collaboration. For a project of this size and complexity involving numerous stakeholders from different disciplines, BIM ensured that all parties had access to the latest project data and were working from the same up-to-date information. This significantly reduced the risk of miscommunication, errors, and delays. BIM also played a crucial role in helping the project meet its sustainability targets. Through detailed simulations, the project team could evaluate the environmental impact of different construction materials, optimize energy use, and design more efficient building systems. BIM allowed the project team to identify potential issues early on and adjust designs accordingly, resulting in better overall resource management and minimize wastages. Recently, I managed to interview Mr. Mohammad Sharil, who's assistant engineering manager, a key member of the project from Potra Pharma, who played a leading role in the warehouse project. With significant experience in the field, Mr. Sharil shared invaluable insights into how IBS and BIM were utilized in the warehouse project to achieve its ambitious sustainability goals. Mr. Sharil explained that one of the primary benefits of IBS was its ability to reduce material waste and streamline the construction process. The prefabrication of key components off-site allowed the project to avoid many of the inefficiencies associated with traditional construction methods. In addition, IBS helped improve quality control as components could be manufactured under controlled conditions, reducing the likelihood of defects. He also highlighted the critical role of BIM in managing the project's complexity. By providing real-time data to all stakeholders, BIM enabled project team to make more informed decisions and resolve issues before they cause delays. Mr. Sharil emphasized that BIM was particularly valuable in coordinating the efforts of the many different teams involved in the project, ensuring that the warehouse was en route to be completed on time and within the specified budget. So you can refer to this interview video after this. Thank you. Good evening, Mr. Mohammad Sharil. Thank you so much for taking the time to speak with me today. It's an honor to hear from someone with such a vast experience in Kotra Pharma Company infrastructure development, particularly with your involvement in new warehouse project. Before we dive into the project, could you share a bit more about your role in Kotra Pharma and your career journey?
Yeah, thank you, Mr. Makrand. Thank you for having me. I have the privilege of working in the engineering sector for over 12 years, and at that time, I've been seen and got involved in many Kotra new manufacturing facility projects. In Kotra, I currently serve as Assistant Engineering Manager, where I lead our effort in delivering high-quality engineering service for Kotra. Over the years, I have the opportunity to work on a variety of projects, including a warehouse project, which has been one of the most rewarding and challenging project of my career.
That's very impressive, Mr. Sharil. Moving on to the warehouse project, Kotra's engineering team played a crucial role in setting its right direction and execution. So could you tell us more about your team's specific contributions to the warehouse project and how your team helped shape outcome of such an important initiative?
Yeah, absolutely. As you know, we are being part of Kotra Pharma team. We are deeply involved in various aspects of warehouse project. We contributed significantly through our expertise in detail engineering design, project management, and by integrating building information modeling (BIM) into the project workflow. BIM allow us to streamline the design process and coordinate with multiple stakeholders, ensuring smoother communications and fewer on-site challenges. Our team also focused and consulted and optimizing construction method and use of a prefabricated component structural and material, improving overall project efficiency by incorporating industrial building system, which is IBS.
Yeah, that's great insight. Every large-scale project comes with its fair share of challenges. Can you tell us about the key challenges Kotra and your team faced during the warehouse project and what innovative approaches your team employed to overcome them?
Yeah, indeed. Large infrastructure projects like warehouse are complex and the scale brings numerous challenges. One of the biggest hurdles was managing the coordination between different stakeholders and ensuring that advanced technology like BIM were properly integrated. Additionally, there were logistical challenges, especially when it came to ensuring that all project elements stay aligned with the tight deadline and environmental standard. Our use of BIM helped mitigate many of these issues, offering real-time data and allowing for faster decision-making process. Another innovation we introduced was a more modular approach to project management, which is a help streamline operation and improve collaboration across team.
Yeah, thank you. So, moving on to my next question. Sustainability has become a major focus in modern infrastructure development. Could you share how your team incorporated sustainability into warehouse project and how technologies like IBS and BIM contributed to achieving these sustainability goals?
Yeah, for this sustainability is indeed at the forefront of modern engineering and warehouse project was no exceptions. Our team ensured that sustainability measures were incorporated right from the planning stage by using IBS and BIM. We were able to optimize resources management, reducing material waste and energy consumption during the construction phase. The use of energy efficient system and improved workflow and prefabricated component and material play a role in lowering the overall carbon footprint, overall environment impact to surrounding and construction time, and it can enhance resource efficiency. We managed to obtain around 30% in reduction of material waste and made construction time 20% faster.
That is quite an achievement, Mr. Sharil. So, before we conclude, what are the key lessons you have learned from your experience with the warehouse project? And what advice would you offer to professionals looking to implement technologies like IBS and BIM in their projects?
Yeah, for this, the warehouse project taught us a lot about the importance of adaptability, communication, and collaboration. One of the biggest lessons is the value of integrating advanced technology early in the project life cycle, as it allows for better planning and resources management. For professional looking implement IBS and BIM, I would advise them to invest in training and ensure all the stakeholders are all on board with the technology. Additionally, flexibility is a key. Be ready to adjust your strategy and new challenge arise, and always maintain a clear communication between teams.
Yeah, that was quite good insight. Thank you so much, Mr. Sharil, for showing us uh, or sharing your valuable insights and experiences today. The warehouse project has certainly set a benchmark for future infrastructure developments for Kotra's upcoming manufacturing expansions. We look forward to seeing more of yours and Kotra's innovative contributions to the pharma industry.
Yeah, thank you for the opportunity to share. It's been a pleasure speaking with you. Thank you again.
Thank you and have a good evening to you, sir. Thank you very much.
All right.
With this, we end our this interview. Yeah. Thank you, sir,
All
again.
right.
Now let's understand impact on sustainable development goals. The warehouse project made significant contributions to several of United Nations Sustainable Development Goals, particularly the goal SDG 9, which is industry, innovation and infrastructure, and the goal SDG 12, responsible consumption and production. By using innovative technologies like IBS and BIM, the project demonstrated how modern infrastructure can be built in a way that is both efficient and environmentally responsible. The Sustainable Development Goal 9, number 9, emphasizes the importance of building resilient infrastructure and fostering innovation, which the warehouse project achieved through its adoption of IBS and BIM. These technologies allowed the project to optimize resources, reduce material waste, and minimize energy consumption, which we have discussed in the previous slides. Additionally, the project contributed to Sustainable Development Goal number 12 by creating a modern, highly efficient automated warehouse that reduces carbon footprint, helping company, which is Kotra Pharma here, leaping towards more sustainable practices and operations. Actually, as we saw, Kotra Pharma has invested in this initiative or new infrastructure such as such a complex warehouse to improve the efficiency in its operation and reduce its carbon footprint, whereby they were using lorries to transport the products from their one warehouse to another warehouse, which were replaced by automated guided vehicles which were based on the battery operation. So they completely eliminated the use of lorries. Also, these processes now efficient because it can run without human intervention with the help of guided vehicles which can run 24/7, and they can bring these pallets from various production facilities or manufacturing areas to the warehouse 24/7. Kotra Pharma's operation run 24/7, and hence they needed such a solution. So these are the impact on the sustainable development goal. Now let us understand challenges and its solutions. Like any large infrastructure project, the warehouse project faced several challenges during its development. One of the most significant challenge was the initial cost of integrating IBS and BIM itself. Both technologies require substantial upfront investment in terms of software equipment and workforce training. Additionally, there was a learning curve for some team members who were more familiar with traditional construction methods. However, these challenges were overcome through strategic planning and investment. Comprehensive training programs were implemented to ensure that all team members were comfortable using IBS and BIM. The long-term benefits of these technologies, such as reduced material costs and faster construction times, far outweighed the initial costs. The project team also had to navigate logistical challenges, particularly in coordinating multiple stakeholders. BIM was instrumental in overcoming this challenge by providing a central platform for real-time collaboration, ensuring that all parties were aligned and working towards the same goal. Now, let us look into the details of outcomes and benefits. Kotra Pharma's warehouse project successfully met its sustainability goals, thanks in large part to the use of IBS and BIM. The project achieved a 30% reduction in construction waste, a 20% reduction in energy consumption, and significant improvements in collaboration and communication among stakeholders. These technologies not only contributed to the project's sustainability goals, but also improved the overall efficiency and quality of the construction process. Looking ahead, it is clear that the wider adoption of IBS and BIM has the potential to revolutionize the construction industry. By investing in these technologies, companies can enhance their competitiveness while contributing to global sustainability efforts. As urbanization continues to increase in Malaysia and other parts of the world, the use of IBS and BIM will be critical in ensuring that new infrastructure projects are built in an environmentally responsible and cost effective manner. Now, let us understand lessons learned and future implications. One of the key lessons learned from the warehouse project is the importance of early integration of advanced technologies like IBS and BIM. Here, management support is very crucial. By adopting these technologies from the outset, the project team was able to optimize resource use, improve efficiency, and significantly reduce the environmental impact of the project. IBS and BIM also demonstrated their value in enhancing communication and collaboration among stakeholders, reducing the likelihood of errors and delays. Moving forward, it is clear that IBS and BIM will play an increasingly important role in the future of construction. As cities continue to grow and infrastructure demands increase, the need for sustainable construction practices will become even more urgent. The warehouse project has set a precedent for how IBS and BIM can be used to create more efficient, sustainable, and resilient infrastructure, even for small business manufacturers, small and medium scale manufacturers. So they also can employ such practices. So in conclusion, I would like to reiterate that industrialized building systems (IBS) and building information modeling (BIM) have proven to be essential tools in promoting sustainability within the construction industry. As demonstrated by the warehouse project, these technologies offer a range of benefits, from reducing construction waste and energy consumption to improving collaboration and project and manage project outcomes. As the world faces increasing environmental challenges, the construction industry must embrace technologies like IBS and BIM to build a more sustainable future. The adoption of these technologies will be key to creating resilient, efficient infrastructure that can meet the needs of the both present and future generations. Thank you for your attention, and I hope this presentation has provided valuable insights into the importance of IBS and BIM in sustainable construction. Thank you for listening to me. With this, I end my presentation.